Excited to be here with all of you. And yeah, today we're going to focus primarily on maintenance and troubleshooting of our valves, both the 800 series and the 1000 series. I think we've got a pretty diverse audience from kind of all around the world, actually, and with probably varying ranges of experience. So this is going to be a pretty fast webinar, but we'll do our best to kind of make it useful for every one of you. First, we're going to cover some things just on service. What are the regularly serviceable items on the valve? We're going to talk about a few ways to prevent problems. We're going to go over some common symptoms. And then at the end, we'll just go over some resources of where you can find help if you need it, as well as we'll have a few minutes for questions at the end. Okay, so really for any basic maintenance and troubleshooting questions, we really need to start with a basic understanding of how the valve works. And so real quickly, I'll just highlight the various parts of the valve so you know what I'm talking about when we dive in here. In the 1000 series, those are our plastic valves. It has a cage, the rubber sleeve, which is the only moving part, the outer jacket, and then a spacer on the inlet side of the valve. The 800 series is very similar. The only difference is it's made out of metal and it has two cages, one upstream and one down. And then it has the same style of sleeve, jacket, and the center barrier to seal the flow off. This is a little animation that shows just in a real simple way how the valve operates. The valves are normally closed. They require pressure to open. When pressure is applied to the valve and the water is evacuated from the control chamber, the valve opens. And then when pressure is applied to the control chamber, the valve closes. So we'll watch this animation one more time so you kind of get a feel for how it works. Again, this area here we call the control chamber. When it is vented to atmosphere, that's when the valve is allowed to open. So pretty much if you can kind of memorize that animation, you are ready to troubleshoot just about any problem you could see in a valve because it's pretty simple. This is really the only moving part in the valve is that rubber sleeve. And so if we just think about how water can get into the control chamber and how it gets out of the control chamber, that usually makes it a lot easier to troubleshoot any problems that we might see. So what are the items that need to be serviced on a regular basis? The pilot O-rings are probably the most common thing. You know, when I think of maintenance, I think of things that need to be, you know, replaced or lubricated or cleaned on kind of an annual basis or some regular interval. And really the valve doesn't have many parts and pieces that are that way. The only thing that might be that would be the O-rings inside the pressure regulating pilot. So there is a service kit available. This is the part number for the small body brass pilot. There's a service kit for the large one as well. It includes this, this sensitivity bushing as well as these critical O-rings here. Now, the most common O-rings that are going to need to be replaced are probably those two. They're the items that wear the most commonly because they're attached to that spool. And as the spool moves up and down, those O-rings rub inside this Teflon bushing and they can become worn down, especially in really poor water quality. If you have a system that regulates, you know, across a wide range of pressures, then those O-rings are going to get worn more quickly. Also, if you fail to winterize the pilot and it freezes, what can happen is the ice can push the spool up and it can hold on to the O-rings and rip them off the spool. And so those O-rings can get torn. So those are a common item to replace potentially in the spring. If you fail to winterize, the symptom you'll see is the valve will continually leak out the vent line. And if it's kind of first thing in the winter, you probably know that's the first thing you need to look to replace. For pilots that are built before 2014, there's an upgrade kit. So this service kit won't work for pilots that are older than 2014. So you need to do an upgrade kit first, which includes a new design of that spool diaphragm assembly, as well as the sensitivity bushing. Another item that needs to be regularly cleaned would be the filter screen. Plugged screen will prevent that valve from closing. And then solenoids are probably the weakest link in any of the valve systems. They have a small orifice in them and they corrode easily. And so those are probably the most commonly item that's going to fail first. And so having some spare solenoids around is always a good practice. The sleeve is also something that will wear out over time. It's going to depend on your conditions, your water quality. It's going to depend on if you're pressure regulating and what that pressure differential is. But that's probably the other regular item that would need to be replaced. And we'll go over how you'll know when it's time to replace that sleeve later on in the presentation. And then also just miscellaneous tubing and fittings. You know, if the tubing gets chewed on, or if the fittings can freeze, those things may need to be replaced over time. So let's talk more about freezing and winterization. This is probably the easiest way to extend the life of your valve if you live in a climate where freezing is possible. The first thing you should do if your valve is installed vertically would be to remove the drain plugs that are above and below the valve. As well as if it's horizontal, you want to remove the drain plug on the bottom of the valve. Now, some people think that if they just blow the system out like they would, normally blow out any system, that's going to adequately relieve the water from all these bits of tubing and all the accessories that are hanging on the valve. But that's not really the case. We need to do more than just blow the system out. We got to remove these drain plugs. And we also need especially to drain the external filter. Now, if you've got an 800 series, you've got this brass canister and it's got a little ball valve here. All you have to do is open that ball valve, it'll drain it out. If you've got a 1000 series valve with an external filter, there's a plug instead of a ball valve. There's a plug right there. Just pull the plug and drain the water out of the external filter. If you don't do that, I promise you, whether it's brass or whether it's plastic, that external filter will freeze and break over time. Now, it'll handle a couple frost events, but repeated freeze-thaw cycles over the course of the winter, they will freeze. The next thing to do would be disconnect the tubing from the solenoid and the pilot, and you'll want to just kind of disconnect those and let the water drain out, or maybe apply a little bit of air pressure, either just by blowing on the end of the tube or by using an air compressor. And then be sure to either connect that tubing right back up where you left it so that you don't accidentally plumb it wrong, or have those plumbing diagrams handy so that you don't forget how to plumb it in the spring when it comes time to hook it back up. Another common problem that we see is the tubing gets chewed on by coyotes or other animals. And a really simple solution we came up with a few years ago is this tubing protection. You can get it factory installed, or you can order this retrofit kit. There's four 16-inch lengths, and you can just trim those to fit, and they slip right over the tubing. And they do an awesome job of keeping those tubing protected. Okay, let's dive into some troubleshooting. Now, something I always want to remind people when we start troubleshooting is that oftentimes the symptoms appear in the valve, but the problem is somewhere else in the system. Oftentimes we get confused and think, well, the valve is doing this or the valve is doing that, therefore the problem must be the valve. And that sometimes is the case, but sometimes it's not the case. When we're troubleshooting valves, we're really troubleshooting a system. And so we need to look at our pumps, we need to look at the pipes, the air relief, the whole system as a whole to try to find the problem. Now, that'll depend on what the symptom is, and we'll go into that. But just remind yourself when you're troubleshooting a valve problem to kind of back up and take a 30,000-foot view of the project and find out what may be causing, especially pressure problems. So common symptoms, probably the most common thing I hear is that the valve won't close or that the valve won't open. And those things we know, yes, those are valve, the problem is most likely in the valve, right? Pressure fluctuations, though, are the type of problem that the symptom shows up in the valve, but oftentimes the problem is somewhere else. Not always, but sometimes. And then another one I hear often is that the opening or the closing speed is either too fast or too slow. And so we'll talk about how to solve that. Now, I would like to do a poll right now and find out kind of what is your experience. I think Steve will launch that poll for us. If you guys can answer this, what's the kind of the single control valve problem that you most commonly encounter? Is it something with the solenoid? Is it the valve plugging? The valve won't open, the valve won't close. So if you can go ahead and respond to that poll, and then we can take a look at the results here in a second. Steve, do we have the
results? We're getting a lot of people are still voting, so we'll close polling in a moment. There's Yeah, I'm just seeing a lot of people still voting. So I'm going to go ahead and end polling here in a few seconds. So if you've not voted yet, please do so, and we will share with you the results, and then you'll be able to see what are common problems as well. So, okay, I'm going to end the polling, and as you expected, Evan.
The weakest link seems to be the solenoid. It
Yeah.
generally is the biggest problem. Yeah, and then plugging and opening and closing. So let's dive into a couple of those real quick and see what do we do about the valve when it won't close. We'll start there. So as you guys know, there's a filter on the valve, and we all know the purpose of the filter is to, make the dirty water clean, right? And the point of that is to prevent that dirty water from getting into the solenoid and getting into the control pilot and damaging either O-rings or plugging things up. So if the valve won't close, the very first thing we should look at is the filter. If that filter is plugged, then we know that the water can't enter into the control chamber to close the valve off, right? And so here's an example of an external filter screen that's probably time to be either cleaned or replaced. This particular screen looks like it's had a lot of iron deposit on it. And so that's the type of screen that probably needs to just be replaced instead of cleaned. And then I'll show you another example here of a filter that has a little bit of a problem. This filter doesn't have a screen at all. I once had a customer call me and tell me the valve wouldn't close, and so we started with the filter, and of course the filter doesn't have a screen on it. And he said, well, that's not a problem. The filter must be fine, right? Well, right there and then we know that if the valve won't close and the filter is missing the screen, that potentially something downstream of the filter is plugged, right? So if the valve won't close still, we've checked the filter looks pretty good. The next thing to do probably is to either look at that solenoid and see if the solenoid has a problem, is plugged or is dead, or is just to open up the valve itself. And then this is kind of the plugging thing that people alluded to in the poll, is if the valve gets something stuck into it, especially the 1000 series, because it only has a downstream cage, it won't close at all. And so this is a picture on the right. You can kind of see there's some stuff stuck in between the center barrier and the sleeve, and that'll prevent the valve from closing, and just a little bit of water can leak out of this space right here. Now the 800 series can have that problem as well. You can get stuff stuck in the cage that'll prevent it from closing. This is some PVC pipe that is stuck inside that valve. So here's another example of a valve that wouldn't close. They took this one out. They didn't find any trash in it, troubleshoot everything else. But this is a 6-inch valve. It's got 100 PSI reduced down to about 25 PSI. And we know the flow is going this direction. So right away, when I look at that sleeve, I can tell something's wrong with it. We look at the shape of the upstream side of the sleeve, and it's got a curve to it. And so we really should be seeing a sleeve like this one on the right. It's got a kind of a perfect symmetrical hourglass shape. Here's another example of one that's old and needs to be replaced. It's kind of ballooned out, you can see. So if we see that condition, you know the sleeve is probably stretched out and it's time to replace it. The other way you can tell is just when you pull that valve out, you can look right down the middle of it. And if you can see through it, then you know it's time to replace that sleeve. Sometimes though, it's even hard to see through, and what you can do is take the valve out, set it on end, and just put a cup of water on it. And if that cup of water drains out, then you know it's time to replace that sleeve as well. Okay, so what if the valve won't open? First thing we should do, if you have a solenoid on there, is just try opening it manually. Okay, if it opens manually and not electrically, then we're pretty sure that the problem is in the solenoid, right? But if it won't open electrically, then we can try turning that solenoid on. And if it clicks, then we know the solenoid's probably still good. But if the valve still didn't open, even though the solenoid clicked, then we know there's probably a plug somewhere. So a place to check for a plug would be the vent or in the solenoid itself. Now we have this little restrictor that we've added to the vent line. And so those, are a potential. If you have really hard water, those can plug up over time. You can actually trim that restrictor right there. There's a little indentation. You can trim it if you want to make that valve open a little bit faster, or if you want to, reduce its susceptibility to plugging a little bit, you can trim it off. Or some people pull it off entirely, but that's up to you. Another thing to check then, if the valve won't open manually and it won't open with the solenoid, it's probably time to remove the valve and inspect it for plugging. And here's an example of a valve that's pre-plugged. So this is just a good reminder when you first put a system in to flush the lines out real well before you install the valve, because yeah, it's not going to pass a lot of this trash. And thankfully so, because if it went downstream, it would probably plug every one of your sprinklers or your drip system or whatever you've got going on, right? So this is another thing to look for if the valve won't open. Okay, pressure fluctuations are another thing that can show up, and they can be really hard to solve. And the reason is because the symptom is usually in the valve, but the problem may or may not be in the valve. The problem may be somewhere else. The most common cause of pressure fluctuations in a system is air in the pipelines. If it could be air in the riser assemblies, it could be air in high spots in the field. But that air basically acts as a big balloon in the system, and it expands and it contracts and it causes those pressure fluctuations. And the valve does what it's supposed to. It responds to the pressure changes. And so if there's something like air stuck in the system, the valve is just going to constantly try to adjust to compensate for that expansion and contraction of the air in the system. So we really need to get the air out of the system. Oversized valves can also cause pressure fluctuations. And that is because as they try to throttle down, they may not be able to adjust finely enough in order to get the pressure dialed right where it's supposed to be. In other words, it'll start to open a little bit, but it lets too much flow by, and then it starts to close a little bit, but not enough flow is going through it. And so that's what happens when you have an oversized valve. As well as if you have the wrong sleeve inside the valve, that can cause pressure fluctuations. In general, when I'm trying to decide between which sleeve to choose, I choose the one that's the higher pressure of the two that will work for the conditions that I have, and we'll go over that in a little bit. VFDs can also create pressure fluctuations because the VFD is trying to compensate for the pressure, and so is the valve. And so the VFD and the valve can start to talk to each other. And so sometimes all you have to do is turn the sensitivity on the VFD down a little bit, and that can help the cycling go away. Turbulence can cause pressure fluctuations in the valve. So when we do our valve assemblies and our manifolds, we want to make sure we have at least like a couple, 3 pipe diameters upstream and downstream of the valve if possible, because that helps the flow have less turbulence as it comes in and out of the valve and gives the valve a better chance of regulating. And I realize in a lot of applications, we don't have that kind of space because we're limited by our crop spacing or our row spacing. So I guess the rule of thumb there is just if you have the space available, give yourself a little extra space so that the valve has less turbulence and it'll have a better chance of regulating. So if you have those problems, what do? Well, the first solution for air is to get it out using continuous acting air vents. Don't go cheap and use the 2-way ping pong ball style air vents everywhere on their system. It's okay to have a couple of those, like maybe a big one right at the outlet of the pump, at the discharge of the pump. But otherwise, you should have continuous acting air vents throughout the system. That's all high points before and after your valves, on top of your filter stations, and that'll help get the air out as good as possible. And then check your flow and your pressure and verify that you have the right valve for the application. Okay, if your flow is too low, then we need to get a smaller valve in there. Or if you have the wrong sleeve because the pressure is too low, or too high, then we need to get the right sleeve in there. So check your flow and your pressure, and then we can make adjustments to the valve accordingly. And then kind of finally, as a last resort, we can play with the opening and closing speed of the valve. And this one can be a little bit tricky because sometimes making the valve open faster or slower will solve the problem or make it worse. It kind of depends on what's causing that pressure fluctuation. And so it takes a little bit more patience, a little bit more trial and error as you start adjusting that opening and closing speed. And we can do that using different sensitivity bushing in the pilot. We can use it using we can accomplish it using different solenoids, or we can also do it with a needle valve if we have to. I see a couple of questions coming in, and those are great. Please keep submitting those, and then Steve will moderate those for us at the end of the presentation here. So on the operating pressure, this is something when we're specifying valves that we can really avoid a lot of problems if we choose the right pressure ranges ahead of time. And these are things that people get confused about on a regular basis. So the pressure range of the sleeve is denoted by this range 10 to 50, or for a medium, 18 to 80, or 30 to 200 on the 800 series. And the ranges are slightly different for the 800 versus the 1000. But what these ranges refer to is the inlet pressure to the valve, a minimum of 10 psi coming into the valve, and a maximum of 50 for the low pressure sleeve, whether the valve is open or closed. Okay, this doesn't have anything to do with what your target downstream pressure is. This is all about how much pressure is coming into the valve. And so let's say I had 60 psi and I was an 800 series valve. I could choose either a medium or a high. Generally, I'm going to choose the sleeve that is the higher pressure of the two, because it's going to last a little bit longer and it's going to resist pressure fluctuations a little bit better. Now, going to the pilot, this is where we're concerned with what our target pressure is. And this is your range of adjustment. All of the pilots are rated to 200 psi. They're not going to blow up below 200 psi. What this is the adjustment range. So if I'm on a drip system and I'm trying to regulate at 12 psi, you know, I could choose any one of these pilots, but I'm probably going to choose the 5 to 30 psi because it's going to be a lot easier to adjust that range of motion. Whereas, you know, if I'm on a sustaining valve, a pressure relief valve, I'm probably going to choose something on this high pressure range because I'm going to want it to relieve pressure above a certain point, and you have a little bit bigger range of adjustment for that feature, right? Okay, let's talk about opening and closing speed real quick. This is a quick diagram that shows how the valve opens and closes. With the solenoid, we have the common port here, and when it is de-energized, it is connected to the normally open port on the solenoid, and the water goes into the control chamber and closes the valve. When I open the valve, or when I energize the solenoid, I allow water to get out of the control chamber and go through the vent. So if I'm trying to adjust my opening and closing speed, I need to use a solenoid with a correctly sized orifice. If I have an 8-inch valve and I use a solenoid with a really small orifice, it's going to open really slowly. So if I want an 8-inch valve to open really quickly, I use a solenoid with a big orifice. Likewise, if I have a valve that I want to open slower, I can use a solenoid with a smaller orifice. So what should every good service person have in their toolbox? I would have some spare fittings and some extra tubing if I need to replumb valves, as well as a tube cutter. A lot of leaks can be avoided if you can cut the end of the tubing off flush before putting it into the fitting. If you have kind of an angled cut on there, then those can leak and that can create problems. I would have in my toolbox some of my common solenoids that I use in my area, because as we've shown in our poll, solenoids are kind of the weakest link. I would also have a pressure gauge, and I would have this lock-on chuck for Schrader valves. We started with 1000 series putting Schrader valves on all pressure reducing valves, and then this last year we've done the same to the 800 series valves. And so now there's a location where you can very easily read the pressure using a Schrader chuck and a pressure gauge. And that makes troubleshooting problems so much easier, because people always say, when you ask them what the pressure is, they say, well, I've got 80 psi back of the pump, so I know I'm good. But the pump's a mile away. So we need to know what the pressure is doing at the valve. And the best way to do that is with the pressure gauge like this and the Schrader valves that are installed on the valve. Also, if I had a lot of 800 series valves in my territory, then I would have a brass pilot upgrade and service kit so that I can quickly service the pilot and the O-rings there if necessary. And then finally, where do I go for help? NelsonIrrigation.com has lots of awesome resources for you. There's a valve manual there with plumbing schematics. There's parts in there, drawing files for your designs. There's maintenance videos. You can also get those maintenance videos at YouTube. Our channel name is Pivot Irrigation, and there's lots of videos there on how to take apart valves. There's plumbing logic videos, good resources there. You can also call your Nelson territory manager to call customer service. You can send me an email. You can call me. We're available to help just about any time. With that, are there any questions? We'll dive in. Steve?
Great. Thank you for that, Evan. There are a few questions. So question one, where are the valves made?
So all of our valves are made right in Walla Walla, Washington. They're made from parts that are sourced in the United States of America. So we don't have a foundry at our factory in Walla Walla, but the castings for the metal parts come from castings primarily made in Washington, Oregon, and California. And then all the plastic components are molded in-house there in Walla Walla.
Great. CJ had asked a question about, can we get he asked this early in the presentation, can we get an explanation on how to winterize a valve pilot, which we did brush on that, but we've got that information on the website. Is that correct?
Yeah, but yeah, the best way to do it is simply to disconnect those tubes. You can blow through some of them. Others will just drain out on their own, but that's probably the best way to do it.
Okay. And there's more information in detail. You've got a PDF document. I've seen it. Okay. Yeah. So, and Lars is wondering, how would you properly size a pressure regulating valve? Is there a minimum and maximum loss through the valve? So proper sizing of regulating valves.
No, that's a really good question, and I might pass on that one right now. Lars, I apologize. I'm going to pass on it just because we only have a couple minutes, and I think that might be a really good reason for us to have another webinar, probably on valve sizing and regulation ranges.
So that one, and so Saul asks, how much space should I give to reduce turbulence? I think he's meaning pipe diameters up or down.
Yeah, you know, if you're doing a standard pressure reducing valve, I think 2 to 3 pipe diameters is enough. But that assumes that you're not having, like, if you have a butterfly valve right upstream of our valve that's going to be throttled, then you're going to want maybe 5 pipe diameters. But if you're just kind of normal fittings, I would say 2 to 3 pipe diameters is fine. As well, if you're using a rate of flow valve, you'll want 5 pipe diameters upstream of the valve.
Okay. Alex is asking, how have sleeve changes from old style to new style in some of the valve styles? I know that the 800 series, there was the case, like in the 4-inch. Any on the 1000 series? Were there sleeve style changes in the 1000 series?
We haven't changed any styles of sleeves in the 1000 series so far. However, in 2018, we did get a new supplier and a slightly different compound of the medium sleeve. And so if you have a medium 2-inch 1000 series sleeve prior to 2018, those have been replaced with a newer compound. They're interchangeable, and the newer one I like just a little bit better. I think it regulates, it's a little more stable for pressure regulation. Yeah.
Okay. A question, Kellen is asking, what is the best way to prevent water hammer on startup? And Kellen comes from a pivot market.
That's a fantastic question. The best way to prevent water hammer on startup is to use a rate of flow valve. We didn't cover rate of flow in this presentation at all. We could do another one on it, but the rate of flow valve will limit the flow rate through the valve, and that is the best tool to prevent water hammer. Hands down. Okay,
good. One last question. I have problems with flanges leaking on my wafer style valves. What's wrong?
That's a great question. So usually if there's leaks right at the flanges, it's probably because they're over torqued or they are unevenly torqued. And so when we have PVC flanges or metal flanges, it's really important that we get the valve aligned. And that if you're using any type of flange other than a Nelson flange, it should have a gasket on it. And then you just want to make sure that you tighten those just like you tighten the nuts on your, the lug nuts on your car. You got to go crisscross applesauce, right? So you get them evenly tightened. Yeah.
Great. Well, Evan, we're out of time. We're out of questions. Thank you for your presentation today. Thank you to everyone who participated in today's webinar. We really